Hi, welcome to Chemistry Unit 3, 3.3 on balancing equations. Today we're going to look at equation terminology, there's of course a song, and two methods of balancing. First, let's start with equation terminology. You're going to be given an equation that looks kind of like this. The left-hand side of the arrow are known as the reactants. The right-hand side of the arrow, anything that's over there, are the products. So in this equation, the reactants are nitrogen and hydrogen, N2 and H2, and the product is NH3, which you should be familiar with as ammonium, or ammonia, sorry. The arrow means yields, makes, or produces. Now, some equations have one reactant and multiple products, but the process for solving them is exactly the same, no matter what's on the left and what's on the right. So don't rewrite the problem. We're going to use a method of balancing to add coefficients. Coefficients give the number of each molecule. They're a big number out front, hence why I didn't want you using big numbers before. They also they multiply the atoms behind them to make the total number of each reactant equal the total number of each product. So when we add coefficients to this equation, we need 1 N2, 3 H2, and 2 NH3. Here's a song.
So, you want to make a product, something you can sell, so you can make some money, your life will be so swell. You make up a reaction to make the stuff you need. You hire up some chemists and build a factory. Don't break the law, don't break the law, don't break the law, don't break the law. How much reactant do you need to get the product made? You play the game of balancing that's been a long time played. In front of all the formulas, each coefficient goes. Make sure you use a pencil. Be steady on your toes.
There are two primary methods of balancing, the block method and the table method. And the directions seem really kind of complicated, but once you see it, they're not too bad. So the block method, first you write the equation, then you do what I call atomize. You write the equation out as individual atoms grouped together in blocks or compounds. You have to keep the compounds together. Then you compare the reactants, that's the left side, and the products on the right side to see where they don't match. And you start adding blocks, filling them in as you go to make the total number of each product equal the total number of each reactant. Then, once you get everything to be balanced, hence why it's called balancing, you count the total number of layers and those become your coefficients. Let's look at an example. Block method example, you're given this equation, Fe plus O2 makes Fe2O3. So step one is to atomize. Notice I kept the plus signs and I kept the arrow, but I looked at things as what they were. So this is Fe, iron, 2 oxygen, 2 iron. Notice it's not FeE, it's FeFe, and 3 oxygen. Now, this is my dividing line, okay? So if that's my dividing line, I'm going to start adding blocks to my compound, right? So I put my compounds in blocks, and I'm going to start adding blocks because on the left I have 1 iron, and on the right I have 2. So I have to add a block, okay? Now that's balanced. I have 2 oxygen and 3 oxygen, so I have to add a block of oxygen. But now I have 4 oxygen and 3 oxygen. And no, you can't just shove an extra oxygen in there. It's not how it works. So I have 4 oxygen and 3 oxygen. So that means I have to add a block over here. But now I start over. I have 4 iron on the right and 2 iron on the left. So I have to add 2 more blocks over there. Now I have 4 iron and 4 iron. I have 4 oxygen and I have 6 oxygen. So when I add a block of oxygen, I get my final answer because everything is balanced. 4 iron, 6 oxygen, 6 oxygen. And my answer is the number of layers. 4, 3, 2. It's not the number of atoms, it's the number of layers of blocks. The table method instructions, again, seem a little complicated, but they're really not. You write the equation with blanks for coefficients out front. You make a table to show each element, the number of atoms on the product and reactant side. You look for where they don't match. You add coefficients to the equation where the elements didn't match, and then you change your table to reflect the new number of atoms. Remember, a coefficient multiplies whatever's behind it. Okay, and you continue to do this process until everything matches. Let's look at an example. Same problem, so you know what the answer is going to be in the end. But when we start this, we make a table. That's why it's called table method. For the elements, the reactants, and the products. So the elements that I'm using in this equation are iron and oxygen. In the reactants, I have 1 iron and 2 oxygen right now as it is. In the products, I have 2 iron and 3 oxygen. Remember, that's what those subscripts mean. So starting at the top, iron doesn't match. So I add a coefficient of 2 and I change my table that now I have 2 iron. Okay, so now my iron matches. My oxygen doesn't. So I add a coefficient of 2. Now I have 4 oxygen as a reactant, but it doesn't match. I add a coefficient of 2 and I change my table. So I now have 4 iron and 6 oxygen. But now my iron doesn't match. So I cross the 2 that I put there. This is why the song says use a pencil. And put a 4 and change my table. But now I need to fix this. So I cross out the 2, change it to a 3. My table now becomes 6 oxygen. And it is balanced. You're going to be practicing this today on an assignment. Thanks for watching.